Hello everyone! Welcome back to our video lesson series on Science Investigatory Projects, or SIP for short. In this episode, we'll be diving deeper into Chapter 1 of your SIPs and exploring the important parts you'll need to include. Are you ready? Let's get started. At the end of this lesson, you are expected to identify and describe the key components of Chapter 1 of a Science Investigatory Project, SIP. Create own examples for each part based on a chosen science topic and participate in group discussions to share examples and insights, fostering collaborative learning and deeper understanding of the research process. In this episode, we will break down the different parts of Chapter 1 of your SIP, focusing on why each part is essential for your research. First, let's talk about the introduction. The introduction provides an overview of the project, explaining what it is about, why it is important, and what you hope to learn. It sets the stage for the research, engaging the reader's interest and providing context for why the study matters. Example: in this study, we will explore how the amount of water affects the height of bean plants. Water is vital for plant growth, and understanding how much is needed can help us grow healthier plants. By structuring your introduction this way, you will effectively set the stage for your research and engage your audience or reader right from the start. Remember, a strong introduction can make a big difference in how your research is perceived. Another important component of the introduction is the background study. This section provides context for your research. Explain what your topic is about and why it matters. It helps readers understand the existing knowledge and significance of the research topic, showing why the study is relevant. Example: water is essential for plants. It helps them grow and thrive by enabling photosynthesis and transporting nutrients. Without enough water, plants can wilt and die. This background helps readers grasp the significance of the research topic and its implications in real-world scenarios. Rationale or purpose. It explains why you chose this topic and what problem you want to solve. It clarifies the motivation behind the research, helping readers see the value and necessity of the study. Example: this study aims to find out which amount of water, 50 milliliters, 100 milliliters, or 150 milliliters, results in the best height for bean plants. This information will help gardeners understand how to care for their plants better. This section outlines the reasoning behind the research and explains why the chosen topic is significant. Understanding the rationale helps convey the necessity of the study to the audience. Next, the overview of the problem. This section presents the main problem that the study seeks to address. It defines the scope of the research, guiding the direction of the study and making it clear what will be investigated. Example: the main question this study addresses is, how does the amount of water given to a bean plant affect its height after 4 weeks? In this example, the focus is on the relationship between two key variables: the amount of water provided and the height of the bean plant after a specific duration, 4 weeks. By framing the research question in this way, the study aims to discover how different watering amounts can influence plant growth, which is crucial for understanding proper plant care. Next component of the introduction is the objective of the study. The objectives outline the goals of the research. They provide a clear focus for the study, helping to measure success and keep the research on track. Example: the objectives of this study are: 1. To determine how different amounts of water affect the height of bean plants. 2. To identify the best watering practices for growing healthy bean plants. These objectives are well-defined, achievable, and relevant to the overall purpose of the study. Next is the statement of the problem. This section clearly defines the specific problem that the research seeks to address. It often includes the research question. It provides a clear focus for the research and outlines what the study intends to solve or investigate. Example: the main problem this study addresses is, how does the amount of water given to a bean plant affect its height after 4 weeks? This statement clearly outlines what you are investigating. It specifies the independent variable, which is the amount of water, and the dependent variable, which is the height of the bean plants. Additionally, by including a specific time frame of 4 weeks, it provides a clear scope for your research. This kind of clarity not only guides your experiment, but also helps you focus on finding a solution to the problem you've identified. Remember, a well-defined statement of the problem is the foundation of any successful research project. Next is the research question. This is the specific question your study aims to answer. It guides the research and helps in forming hypotheses, ensuring that the study remains focused and relevant. The research question is derived from the statement of the problem and helps you narrow down your focus. Example: how does the amount of water given to a bean plant affect its height after 4 weeks? This question is effective because it clearly indicates what you'll be examining. It specifies 2 key elements: the variable you are manipulating, the amount of water, and the outcome you will measure, the height of the bean plants. A well-crafted research question not only guides your experiment, but also sparks curiosity and drives your investigation. So, make sure to frame your research question clearly and specifically to lead you toward meaningful results. Hypothesis. A hypothesis is a testable prediction about the outcome of the research based on existing knowledge or observations. It is an educated guess that indicates what the researcher believes will happen in the study. The hypothesis helps guide the research process by providing a clear direction for what the investigation will test. It is important because it allows researchers to focus their study and analyze the results in relation to the prediction made. Example: if a bean plant receives 150 milliliters of water every day, then it will grow taller than a bean plant that receives only 50 milliliters or 100 milliliters of water, because more water will provide better hydration and nutrients for growth. This example effectively captures the essence of a strong hypothesis, providing a clear and testable prediction supported by logical reasoning. Significance of the study. The significance of the study explains why the research is important and who will benefit from it. It outlines the potential impact of the research findings on a broader context. This section helps justify the research by highlighting its relevance, and it informs the reader of the contributions the study can make to the field or society. It clarifies the value of the research beyond just answering the research question. Example: this study is significant because it will provide insights into how different amounts of water affect plant growth. Gardeners and farmers will benefit from understanding the best watering practices, leading to healthier crops and better food production. This example effectively communicates the significance of the research by connecting it to practical benefits for specific audiences, emphasizing the potential for improved agricultural practices and maintaining clarity throughout. It demonstrates how the study's findings could have real-world applications and contribute to better understanding in the field of plant growth. A scope and limitation. The scope defines the boundaries of the study, including what will be included in the research, while limitations are factors that may affect the results or generalizability of the study. Clearly, outlining the scope helps to focus the research, ensuring that the investigation remains manageable and specific. Discussing limitations is crucial for understanding the context of the results and for recognizing potential weaknesses in the study design. Example: scope. This study will focus on the growth of bean plants, Phaseolus vulgaris, over a period of 4 weeks, comparing 3 different amounts of water: 50 milliliters, 100 milliliters, and 150 milliliters per day. Limitations of this study include factors such as the type of soil used, sunlight exposure, and temperature, which may also affect plant growth but will not be controlled in this experiment. Both examples are well crafted and effectively communicate the scope and limitations of the study. They provide clear parameters for what the research will cover and acknowledge external factors that might influence the results, ensuring that the audience has comprehensive understanding of the study's focus and boundaries. Now that we've discussed the key parts of Chapter 1 in your science investigatory project, it's time to put your knowledge to the test with a fun group activity. Let's explore. Each class will divide into 5 groups with 5 to 7 pupils each. Each group will choose one simple science topic to work on. Here are some examples: the effect of sunlight on plant growth, how different types of water affect plant growth, how temperature affects ice melting. Each group will work together to complete the parts of Chapter 1 of Science Investigatory Project. Each group must write a brief introduction, background, purpose, and research question, create a hypothesis, prediction, write the significance of the study, who benefits and why it's important, define the scope and limitations, what you will study and the limits. Each group has 20 minutes to work on their Chapter 1, or they can continue working on it at home if time runs out. Each will present their output to the class. You can click the link in the video description to download an example of a complete SIP, Chapter 1. Let's reflect from your activity. Answer these questions. What did you find most challenging when completing the different parts of Chapter 1, and how did your group overcome it? How do you think the process of creating an SIP can help you better understand how to conduct a real scientific investigation? Let's recap. To summarize, Chapter 1 of Science Investigatory Project includes 1. Introduction. It includes the background of the study, the reason why it's being conducted, rationale, an overview of the problem, the objectives of the research, and the main research question. 2. The hypothesis. A testable prediction about the outcome of your research, often written as an if-then statement. 3. Significance of the study. Explains the importance of your research and who will benefit from the results. 4. Scope and limitations. Defines what your study will cover, scope, and any challenges or factors that could limit the study's results. Limitations. By understanding these parts of Chapter 1, you'll be able to create a solid foundation for your science investigatory project, helping you organize your research clearly and effectively. Now that we've completed the discussion, it's time to check what you've learned. Let's evaluate. Read each question carefully and select the letter of the best answer. Write your answer on your research notebook. Are you done answering? If yes, please submit your answers to your research teacher. Great job, everyone! I hope you learned a lot about the parts of Chapter 1 in your science investigatory project. Remember, every great discovery begins with a curious mind and a solid plan. As Albert Einstein once said, the important thing is not to stop questioning. Curiosity has its own reason for existing. Keep asking questions, keep exploring, and most of all, keep learning. Thank you for joining me today. Until next time, this is Teacher Arlen, signing off. Goodbye.